Good day, everyone. It's Alan Schimmel, editor-in-chief, DevOps.com, Security Boulevard Container Journal, and welcome to another Media Ops webinar. I hope everyone is safe, probably maybe working it from home, and you've taken time out of your busy days to join us here on another webinar. Like you, many of us, including our panelists, are working from home right now. So if you see an occasional cat go by the screen or a child yelling or some other thing, please bear with us. These are not usual times. I was going to say normal, but who knows what normal is. But it's not the usual times, and we're doing the best we can. And the good news is I really think we have a great webinar for you today. This has been a topic that some of you may have seen in person. It's a great topic for folks into Kubernetes and security and trying to understand where's the best place to get Kubernetes. Before we jump in, though, I wanted to just take a moment for housekeeping. We are looking for a very interactive panel today, a very interactive webinar. We encourage you to ask questions, but you can't ask using audio, obviously, and I'm going to ask that you don't use the chat window to ask your questions. I'm going to ask that you use the GoToWebinar control panel, the question section, which is about halfway down for most of you, or towards the bottom maybe. And if you open that up, you'll see you can ask your question in there. And by doing so, it's really great because we can queue them in some sort of chronological order. We could save them for later. We could dismiss the ones that are already answered. It just makes for a much more organized webinar. And we also have a record of it. So if this is like other webinars we've done lately with a lot of questions, we'll have a record. We'll try to maybe get you some offline answers to your questions and concerns, and we'll do the best we can with that. So please use the question section of your GoToWebinar control panel, not the chat session. The chat session is good if you're having a technical problem. Maybe your video's not working well, the audio is choppy, whatever. If you have a technical issue, but you can still get to that chat section, please put it in there. We do have engineers standing by to try to help you with whatever issue you may have. So hopefully that answers your questions today. Let's get in with our webinar. Our webinar today is brought to us by our good friends at StackRox. Many thanks to them. And today's webinar is evaluating the top 3 Kubernetes providers, EKS versus GKE versus AKS. And our webinar presenter is none other than Karen Bruner, Tech Evangelist at StackRox. Karen, welcome.
Thank you.
All right, your audio's working.
Yep, great.
Okay, before we get started, Karen, I thought it'd be a good idea to kind of get a temperature. Well, that's a bad word to use in this time and place. To get an idea of where our audience is in terms of their own Kubernetes journey. So I'm going to put a poll question out here. And guys, the deal with poll questions and webinars, they're only as good as your participation. So please take a moment. I'm only going to leave this up for maybe 10 seconds, so you don't have a lot of time. Well, you got to read it. I'll give it 15 seconds. Read it. It's a multiple choice. Pick one and let us know when we're done, and we can figure that out and see where everyone is. We already have 60% of you voting. That's great. I'm going to keep this open for about 5 more seconds. 5. Come on, folks, vote. 4, 3, 2, 1. All right, I'm going to end voting. And we got almost 3/4 of you voted. And where do I show people? Oh, share results. Okay. And so here are our results on this. So where are you in your Kubernetes journeys? 38% of you, almost 40% are learning. 26% using it in test. 13% are using it in production, but just 1 or 2 apps. 14% for several apps. And only 8% of you are using it in production very extensively. Karen, is that what you would expect? Is that normal? Is that kind of the market in whole?
I, our Michelle, I don't know if she's listening. Michelle, our marketing lead, would know better.
Yeah. We've done a lot
yeah.
of polling broadly. It's about in line. We tend to see, if you tally everybody who said that they were in production, it's about a third. Our own polling skews a little higher because we tend to talk to people that are already in our universe, and use of Kube is a little bit more prevalent. But I think that that's about the norm for broader audiences that we've seen.
I've done, I was an SRE and DevOps lead for a long time, and I tend to be, I personally, when I'm running infrastructure for a team, I tend to be a little conservative. So that's probably where I'd be. I'd be in test, or I'd be migrating a few lightweight apps. It really does depend if you're either starting from scratch and doing greenfield, or if you're looking at maybe some of your existing legacy apps, which are less likely to migrate. So yeah, that's what I would expect.
Excellent. All right, let's jump in. Karen, I'm not sure. You control the slides. Me personally, I'm seeing this polling question though. Oh, there we go.
There we go. Okay. So I'm just Alan has already introduced me. I also really hope you're all safe. I'm here in California, so we are, especially in Santa Clara Valley, so we've been shelter at home for a week now. I will also warn you that I have cats, and they may or may not make a guest appearance. They may or may not make noise. They like to run around a lot at this time. So as Alan said, I'm the tech evangelist at StackRox. I've been doing that for several months now, it's a new job for me. And like I've said, I did operations infrastructure for a long time. So we're going to talk about the big three cloud providers. They're managed Kubernetes services. Just comparing them. And there are other options, but it's a good comparison just to see what I certainly understand from my experience that a lot of people, if they're already in the cloud, they know exactly, they may not have a choice about choosing what cloud they're in. If you do have a choice, this is interesting, but it's also interesting to see just where the variance is, or know what questions there are. If you're in one cloud provider, that may seem like normal to you, but that may not be normal to somebody who has to work with a different cloud provider. So we're going to talk about versions, what supported versions each cloud provider uses, how much maintenance the user is expected to do versus what the provider does, talk about random features, talk about how they handle cluster networking, security features, and a few other topics depending on time. Sorry, still waking up. Nice little logos. They each have their own logos. I did not recognize the Azure logo for a long time. I will admit that. Okay, so we're starting with the version support matrix.
You know what, Karen? Karen,
go ahead.
I don't want to interrupt you, but we're already getting
No
a
worries.
few questions from folks. And one of the questions is, well, what about if I don't run my Kubernetes in the cloud? Maybe I'm running it on-prem, or I'm running it both. I think that would be a good, if you don't mind, I'd like to poll our audience and see,
Sure.
Are you running it only in the cloud, or are you running it only on-prem, or a mix? It'd be an interesting thing, if you don't mind.
No worries. No, absolutely.
So if you're running Kubernetes today, where are you running it? And you can only select one, on-prem, in cloud, or a little of both. And of course, if you're not running Kubernetes, don't answer, but don't use that as an excuse. If you have an answer here, we'd appreciate the answer. And we're going to close this off in just about 5 seconds. 5, 4, 3, 2, 1. I hope all of you who wanted to vote voted. We're going to close the poll. And the results are, so we've got both on-prem and in the cloud. Really, only 2% below. That's surprising to me. I thought it would be much more in cloud only.
I am not surprised. I've certainly worked in especially older, more established, I don't want to say older, more established companies. They are much more likely at this point to, and I'm biased because I've worked in Silicon Valley a long time, but definitely certain industries and definitely older companies are much more likely to have data centers. So they're much more, and a lot of those providers are starting to support Kubernetes, and there's also good support, various tools for deploying to bare metal, to deploying to hardware. So yeah,
Sure.
it's interesting to see that, but yeah, definitely.
And I'll just chime in briefly. Again, this is Michelle with StackRox. We've been polling, as I mentioned, we do the state of Kubernetes and container security report. We've run it 3 times now. And the interesting thing is the percentage that is on-prem only has declined every time. But the first time we ran it, which was a little more than 18 months ago, it was actually 31% only on-prem running Kube. And so we're seeing a great uptake in the cloud provider solutions. And I think Karen will speak really well to kind of why that is, what it does for you, how it simplifies things. But it has been steadily declining every time we ask that question.
Interesting.
And
Karen, I'm sorry to bother. I don't
no
know if
worries.
everyone's seeing the slides correctly. I'm not.
Yeah,
There
as
we
far as on-prem, obviously on-prem is going to be different. It does depend on how you're managing it, but it's much less predictable how you're if you're doing bare metal, or if you're doing something like deploying on vSphere, deploying on not Mesosphere anymore, D2IQ. So hopefully this will be at least a little useful to you if you're considering using the cloud, or just to see what the variables can be. So hopefully, because they do vary by cloud, but they also vary by different installations of Kubernetes. So, so the first slide, back to the slides, the first slide is just about version support, and this is current as of today. And I haven't actually checked, but today is the official release day of Kubernetes 1.18. It may or may not be live yet. It should be live by end of the day. The release team is really, really good about, and especially in this climate where so many people are changing their work habits, are dealing with, family, kids being at home, just general stressful times. They're still, I've been watching, and they're still just getting things done. So but they're always really good about releasing on the scheduled date. So for Kubernetes, the open source, the official open source, they currently support 3 versions. They have a release cadence of 3 months. So that means that any given version will be supported for 9 months. There is a Kubernetes enhancement proposal, KEP, for extending that so that they will support 4 versions, which means any version will be in support for a whole year. At either way, what this means is that supported means that not only bug fixes, but most importantly, they will port security fixes. This is, so we'll see this, you can see the matrix. All of the providers are still supporting versions that are out of official support. So when there is especially when there is a critical security fix, they will backport that. They will cherry pick that and apply that.
Yep.
So, go ahead, Alan.
No, Karen, so I have a question from the audience on this, because, they look at these 4 categories, and so people want to know, well, what about Kubernetes distributions, such as, let's say, an OpenShift or a Rancher?
Right. I don't have, so Rancher I don't follow very closely. OpenShift, I do actually know this. OpenShift 4.2, I think, is using a version of 1.14, but OpenShift does apply some of their own modifications, and they definitely are backporting versions. So OpenShift, it doesn't, just because a version is out of official support doesn't mean that if it's going through, if you're deploying it through a third party, second party, it doesn't mean that it's not getting crucial fixes. It just means that whatever entity, whether it's a commercial company or another open source distribution, it means that they are responsible for applying these fixes.
Got it.
Yeah. So
Another
you can
question,
see.
Karen. I'm sorry. I'm trying to just
No
knock
worries.
some questions out. What about for people who are running, Kubernetes in these 3, configurations, but they're running them on cloud VMs instead of EKS, GKE, or AKS?
So the thing about all of these providers is that the nodes are actually, in EKS, it's EC2 nodes, AKS, it's their VMs, GKE, it's their, what do they call them? Virtual machines. Yeah. So the nodes are actually just using whatever their virtual machine platform is. So that's absolutely normal. We will get to the maintenance in the next slide. So we'll talk about how the user, there's a shared responsibility as far as keeping up with some of these changes. But
actually,
yeah,
what that
so
question is actually getting at is,
okay.
what about people who are running in the cloud, but they're not using a managed kube service? And we absolutely see that. Yeah, so they're doing self-managed kube in the cloud.
Mm-hmm.
And we see, we do see a good chunk of that. In fact, when we asked our questions, self-managed in the cloud was the number 2 response, really neck and neck with number of people using EKS. So super common and popular.
Okay, so just to go back, I will point out that, so when I talk about, for all 3 of these, again, for Amazon and Azure and Google Cloud, all of these services, and it varies a little bit, but we're talking about what they do manage fully to some extent, what is known as the Kubernetes control plane. And the control plane, if you're self-managing, these are the master nodes. But the control plane includes the Kubernetes API server, which is what you use to manage your cluster. It includes the scheduler, which is what, decides where pods are going to be placed. And it includes the etcd, etc. instance or data store, which stores the current state, which stores the current state of the objects, what resources have been deployed, and so forth. So if you're self-managing, these are on the master nodes. But for these managed services, these are what they manage. So if you're managing your master nodes, you have direct access to these. On these services, you do not.
Very good.
So again, if you're deploying directly to the cloud, you're self-managing. Obviously, it's not at all managed. You're responsible for upgrading not just the worker nodes, but also the master nodes. And obviously, if there are issues, if you have any service disruptions or so forth, you're responsible if you're managing your own cluster. I actually have experience managing on Amazon COPS clusters, which I had to do before EKS was even out. COPS has definitely matured a lot. For test purposes, I've deployed both to Google Cloud and to Amazon. Deployed a couple of different providers. I've tried KubeSpray, which is a little lower, a little less evolved than COPS, but gives you a lot of options for managing. The nice thing about Kubespray is that it supports a lot of platforms, not just cloud platforms, but it's good for bare metal. But it's portable because it leaves a lot of decisions up to the user. So there are trade-offs. COPS is very optimized for Amazon, but it's not so good for Google. It's not as it's getting support for Google Cloud, but the last time I tried it, it was not very reliable. So there are a lot of tools. There are a lot of different options. You just have to see if you're in a cloud and you want to self-manage. You have to decide what tool supports that cloud, and how much. This is always a trade-off. If you're and I've done this before. Some of Amazon's managed services for open source tools are good and some are not. So you have to decide if their managed version has all the features you want, has the visibility you want, but you also have to decide what your operational capacity is. If you have a small team managing infrastructure, sometimes you have to make that trade-off. How much capacity do we have? How much time do we have? How much automation can we put into this versus what do we need from these features? I've had to make that choice. You have to make trade-offs. That's every organization has to make that decision for themselves. So I will say for a few things, AKS Azure has actually been doing a really good job of being very current with versions. That I was a little surprised with that. It's impressive. GKE is a little more conservative. They were actually the last of these three to make 1.14 their default for new clusters. So that to me was a little surprising, because obviously, I don't know whether you know this, Google invented Kubernetes. So you would expect GKE to be the flagship. And in some ways they are, but as far as supporting versions, they are a little slow sometimes compared to Azure. EKS is a little behind. 1.15, they just added support for 1.15 2 weeks ago. So yeah, they're definitely, they have been, at least for the last couple of versions, a little slower to add support. Any other questions for version support?
There was well, not necessarily. People wanted, one question potentially was how mature is Pivotal Kubernetes services compared to these three? It's not version.
Oh, go ahead. I actually have not even looked at Pivotal closely. I've looked at a couple other providers. If you're self-managing, most of those support current versions. Again, my personal experience, COPS officially supports, they're usually lagging behind one version, but I have used COPS to deploy the current version and it usually works. So like COPS built for 1.16 can usually deploy 1.17 without major issues. I've also looked at, I think last week I looked at IBM EKS. They are also about, they supported 1.17, I think still in preview, but there was some parity between Azure and what EKS was supporting.
Do you know why AWS is behind in, I don't want to use the
I don't know officially. I've heard a few rumors, but I can't comment on them. If you go to a conference and you find an actual, or you're in contact with certain release people. So for one thing, I do know that 1.15 is most version changes are incremental, but 1.15 to 1.16, 1.16 removes certain Kubernetes APIs. They were deprecated for a long time. So, and in 1.16, they were finally removed. So that's a big change for a lot of providers. And for some users too, if they've done any coding that relies on certain API versions, or even their manifest, because manifest, for if you're deploying a resource, you have to put what is the API, what is the what is the API that manages this resource? That's a smaller change. But if you're doing code, if you're actually, you've written programs around this, that's a little more work. So 115 to 116 is a big jump. I want to say at this point, most version changes are not nearly as, you see far fewer incompatible version changes.
Yep.
Okay. I will go to the next slide. So looking at upgrades and maintenance, control plane, again, these are the services that manage your cluster. These would be your master nodes if you were self-managing. For control plane upgrades, and again, just a little background, control plane upgrades. So version upgrades, Kubernetes was designed to be very tolerant of version upgrades, but you always want to upgrade. And again, you want to keep your nodes can actually lag behind your master, but only if you want to be safe by one version. So this makes upgrades easier. So you don't have to have downtime to upgrade your cluster. This is very useful. I especially, again, I've been doing operations a long time. Avoiding downtime is very nice. So you can, as long as you upgrade your master and you keep it, or your control plane, and you keep it just one version ahead, you should not have any downtime issues. So let's say my whole cluster is at 115, I want to upgrade to 116, I upgrade my masters first, my workers will still be happy, and then I upgrade my node workers, my worker nodes. So for control plane upgrades, EKS is, the user must initiate, and also there are add-ons. And by add-ons, the definition varies a little bit from cloud provider, but in EKS, add-ons are not only optional services like your autoscalers and any drivers, like if you want to use EFS, Elastic File System volumes, that's an add-on to support. You have to add a controller to support those. But EKS also considers add-ons non-optional services, like that they require to use their VPC network controller and their core DNS, which is now pretty much the standard DNS provider in your cluster. The user must upgrade those services, which is a fair amount. It can be a fair amount of work. AKS, the user has to initiate the control plane upgrades, but they will upgrade these services for you. And GKE is actually much nicer here, because you have a scheduled window for maintenance. They will upgrade these automatically for you. You can opt in, you can opt out, you can say I don't want you to upgrade, but if you opt in, they will just magically do this for you. And I know that 2+ years ago, it was when they were just rolling this out. You cross your fingers, and but now it's very reliable. It's really reliable. And they also do this for node upgrades. You can either, again, opt in, opt out, but they will also upgrade your node versions for you automatically. And again, Kubernetes is made to be really resilient and really tolerant of changes like this. So as long as, again, you have to do the right thing, and by the right thing, I mean you have to, if you're stateless services, you do have to deploy to, use multiple replicas. So if it takes down a node, it will do one worker node at a time. But so you want to have your replicas on multiple worker nodes, but it's if you are following best practices, having these automatic node upgrades, you won't even notice it. There will be zero downtime. EKS, again, for node upgrades, user has to initiate it. EKS supports two different kinds of node groups. Initially, when they started out, they had what are now referred to as self-managed node groups. Both self-managed and their managed node groups were introduced at reInvent last December. both of these are based on EC2 auto scaling groups, which have been around for a long time. But originally, and you can still do self-managed node groups, the user has to create the node group. There's a really good tool that is managed by the company Weaveworks, called EKS CTL. If you are running EKS and you don't know about this tool, use this tool. And it's actually mentioned in the official AWS docs for it, because it's really useful. It will automate a lot of this stuff for you. And you can still do either self-managed node groups or managed node groups. For self-managed node groups, you do have to cycle your nodes. So you can do the upgrade, but you still have to drain your nodes yourself and replace them. Managed node groups will do this for you. That's one of the big differences between the two. Azure user does have to kick off the node group upgrades, but Azure will drain your nodes, and by draining I mean block the scheduler from scheduling new pods to the nodes, and also kill off node pods so that they will be scheduled on other nodes. So that's what draining is. Azure will do that for you for each node. You want to do that one node at a time so that you maintain your uptime for services you have running in your cluster. As far as node health monitoring, and by the node, you want your node to be healthy, and it's not just the underlying VM, but you also there are services that run on your node. You also want to worry about if there's disk space that runs out, if you're running logs, if you're out of memory, if processes die. These are standard nodes. These are all processes. You want to make sure that's healthy. Neither EKS, neither Amazon nor Azure have any built-in node health monitoring. You can roll your own to some extent, but they won't do it for you. Google, on the other hand, will not only monitor your health, but it will actually repair your nodes. And by repair, I mean either if it's something it can fix, it will do that, or it will terminate that node, and so you will get a replacement node.
Fantastic. Karen, if you don't mind, I'd like to butt in here for a second and do our last polling question, which is, let's find out whether people are using AWS or Azure, Google, IBM, or some other. We're going to launch a poll. And we are, guys, I realize it's 1:30 on the East Coast. So I have more than half past the notes, so we'll try to pick it up. If you're running Kubernetes in the cloud, which provider are you? It's just fairly straightforward, guys. Help me out here. Give us some quick votes. We're going to close this one off in like 5 seconds, guys. So pick one or forever hold your peace. 5, 4, 3, 2, 1. I'm closing the poll. I didn't get almost half of the people. The results, as one would expect, AWS. Well, they're all right up there. So fair enough on that, Karen. I don't want to spend a lot of time because I know you have.
No worries.
I know you have slides to work on here. So why don't we? Okay. So I think we do the
we'll
next
talk
slide.
about node features.
Yep.
I will also try to pick up the pace. Node features, operating system. EKS defaults to Amazon Linux, but it actually gives you a lot of options. And they will also, so again, I was talking about self-managed versus managed node groups in Amazon. If you're using the managed node groups, you can only do Amazon Linux. They do have support from Windows. If you're doing self-managed, you have the option of Ubuntu or other images, or you can actually make your own image as long as it has the required services like the kubelet and a container runtime, and it will join the cluster. You can actually use your own image, which is really useful if you want to add monitoring, if you want to add any kind of third-party changes, whatever. AKS, it's Ubuntu or it's Windows. GKE gives you 2 Linux options. You can either use their container optimized operating system or Ubuntu. Container COS is the default, or Windows. All 3. EKS has Windows as GA, which is interesting because Kubernetes support for Windows is not generally available yet, but anyways, Kubernetes itself will support any compatible Linux, and Linux and compatible mostly means your kernel will work. It doesn't really care about distributions. Windows, I think all three, the Windows version has to be Windows Server 2019 or better. Container runtime, again, this is what actually runs your containers. Kubernetes as a whole supports either Docker or any runtime that is compatible with their container runtime interface, which is abbreviated as CRI. What's interesting is that Docker is not actually compatible with their container runtime interface, but they use Containerd, which is a shim. So if you're running Docker, you actually also have Containerd running. Containerd itself will run as a standalone. All three by default use Docker. GKE will actually also, you have the option of just running Containerd instead of Containerd plus Docker. All three have GPU support. You do have to, all three do require you to supply or to install the plugin, the driver to make this work, but you can use, if you need GPUs, if you need graphical, sorry, brain is blanking, processor units, it's an option on all three clouds. And for node pool auto scaling, and by this, sometimes you have workloads that just like bursty, especially maybe data processing, any kind of data processing, where sometimes you don't have any workloads, and sometimes you may have a lot of tasks coming in at once, and so you want a lot of nodes. Kubernetes has a really nice cluster autoscaler. It's very configurable. I've seen it mature a lot in the last 2 years, and you can also bring in your own. But either way, AKS, Azure, and Google is opt-in, but they will manage that for you. EKS does support it, but you do have to install it and manage the add-on service yourself. Any questions about this?
There are
Okay.
questions, Karen, but I think we're going to try to hold these to make sure we get through our slides.
No worries. No worries. Control plane options, and again, control plane is if you're self-managing, this would correspond to your master nodes. Availability, and again, this is what if you're using a managed service, this is the main piece that the clouds do or should manage for you. Availability, EKS, your control plane is highly available. They deploy to 3 availability zones. Azure, the docs don't explicitly state whether it's highly available, which makes me think it's not. I don't know this for a fact either way, but normally, a cloud provider is very, if it's highly available, they will say. So if they don't say, that's a little sketchy. GKE has 2 types of clusters. There's zonal, which means it's in one availability zone. That's not highly available. But if it's regional, which if you have a regional cluster, it does mean that they deploy the control plane to multiple zones, which if one availability zone fails for whatever reason, your cluster the control plane should still be available. The SLAs also vary, especially in GKE, for whether it's zonal or regional, which is expected, but they're all very close. Financially backed SLAs. So this is important. The control plane cost is a small part of your cluster cost, especially if you have a large cluster. If you have, a cluster with 2 very tiny VMs, which you're probably not using for production, that's going to be a much larger proportion of your cost. But EKS right now is the only one of the 3 that has a financially backed SLA, which means if there is downtime, you can, and you're paying customer, they will comp you for any downtime. GKE and Google announced a couple weeks ago that they will start both charging for the control plane and financially backing their service level agreement. that will start, they're expecting that to deploy in June of this year. And that control plane will, whether it's zonal or regional, will cost the same as Amazon's charge. So AKS doesn't have a financially backed display, but they also don't charge you for the control plane right now.
Excellent.
Networking, cluster networking, the Kubernetes cluster network is highly virtualized by default. But whatever is, at this point, either the default plugin is called Kubernetes. This has been around for a long time. It doesn't handle virtual networks, especially if you're using a virtual local area network. It doesn't manage that on its own. So if you're just running on, you're running Minikube or Kind on your laptop, it works fine. But if you have multiple availability zones, you're using multiple subnets, which for a highly available cluster in the cloud is definitely, or on-prem is something you want to do. Kubernetes won't work on its own.
Karen, if you don't mind,
oh, go ahead.
I'm going to ask Michelle to jump in. There were two questions that are similar near the top of the list.
Okay.
And let's answer them so we can keep the flow moving, and because there are a ton of questions, I feel terrible, but I also want to get to the bulk of your presentation. Michelle, would you mind grabbing
yeah, no,
one or two?
absolutely. Yeah, so some people are asking about, if you're in a multi-cloud situation, you're running a couple of them, or if you are trying to do something prem and cloud, and you want some form of consistent monitoring. How could you monitor these workloads across a multi-cloud, or how can you get insights into container health and security services in general across, master and worker nodes? So if you have some comments on how people can get insights at the monitoring level.
Okay. For monitoring, the standard, there are a couple of fairly standard open source tools for monitoring. There's a Kubemetrics service, which does very basic monitoring of your Kubernetes cluster and container health. And you just deploy this as a service. You can also, the standard in service for both cluster metrics and even your application metrics is Prometheus. And these are highly portable. These will work in any Kubernetes cluster. Prometheus does need persistent storage, but it can manage any data. So there are tools built around Prometheus to manage either cross-cluster, multi-cluster, or to aggregate that data. I can't remember. One of them is named, I want to say Thanos, if you have watched any of the Avengers movies for Marvel. But there are a couple of operators and tools built around managing Prometheus, which is, it has some overhead, but it's the most portable way to do it. And you can feed these metrics, even if you're running cross-cluster, different platforms. Prometheus, you can run Prometheus in your clusters and then push those metrics into whatever third party you want. Prometheus has a lot of interfaces and plugins to work with other data metrics aggregators.
Okay, cool. There's another one tied to monitoring security services. And I swear that this wasn't a plant, even though it looks like it could have been a layup for us.
No, absolutely.
But yeah, I mean, one thing that we have seen in some of the customers that we work with who do multi-cloud, some of them choose self-managed Kube paired with StackRox for exactly that kind of universal approach, right? They recognize if they start to adopt some of the cloud specific tools that there could be some lock-in there, and so they're setting policies. They want Kube to be that universal layer, and then StackRox leverages Kube for a lot of policy enforcement. And StackRox can be an emission controller for Kube and things like that. So everything lives in a Kube source of truth, and they get that universality and that multi-cloud portability through the combination of StackRox and Kubernetes to get universal security posture. So I'll just put in that quick plug, even though I swear we didn't tell this guy to, to ask the question.
And just to be fair, just to be, you know, there's a growing ecosystem of open source security. They are not as comprehensive, but if you wanted to cobble some of them together and with some custom code or some custom configuration, there are some options there. One of the most interesting but most difficult, honestly, to manage tools right now is the Open Policy Agent. This will do a lot of, this is an admission controller with Gatekeeper that will help you. Admission controllers will work with the Kubernetes cluster API to allow certain configurations for your resources and deny certain others. It has a very steep learning curve, but it is extremely powerful. So there are options, yeah, definitely. But definitely you want to use something that will run in a third party, you know, not in a third party, in a dedicated administrative Kubernetes cluster and feed data back from your various clusters. Okay, I will, network. So network plugins. EKS requires you to use their VPC. CNI stands for Container Network Interface. This is the plugin API, Container Network Interfaces. This is how Kubernetes lets you create a third-party plugin. Again, Kubernetes is the default. It's the most venerable. GKE actually uses Kubernetes, but there is magic on the back end Google Cloud Network that makes Kubernetes work across their VMs. And AKS allows you to choose Kubernetes, but again, there is magic that makes it work across various subnets. Or you can use their custom Azure interface. AWS requires you to use their network interface, though. But Azure, if you're using these custom interfaces, it puts your pods directly on your cloud network. So this is the same network as the nodes. This may seem useful, and in some cases it is useful, but there is a drawback in that it makes, for security, you really want to separate your nodes and your pods as much as possible. Even though your containers are running on your nodes, you want to segregate them as much as possible, because if an attacker, if any malicious person takes over a pod, if they can get to your node, it's game over. So you really want to be able to separate those. GKE is starting to roll out their what they call IP aliasing. And again, you have that same issue. You're sharing your networks. I don't know about the other two, but GKE documentation does point out that this has benefits, because if you use their IP aliasing feature, you get some security benefits. Like it will make sure you're not spoofing. There's no IP spoofing. So your pods can't masquerade as a node or trick the network, trick any third-party service into thinking that they're on your actual network. Yeah, it's a trade-off. AKS, it does give you the option. It's up to you. And also, if you have a lot of pods, it can eat up your VPC network space. Whereas if you have a private, and by private I mean you have a completely separate network space for your pods, it does give you a little more leeway into how many nodes and pods you can run in your VPC. Network policy support. So the network policy is the Kubernetes standard for, basically and they don't like using the word firewall, but it's basically your cluster firewall. So you can define what pods, which what pods can talk to, what services, what pods, what IP addresses that they can talk to, and what IP addresses and other pods, other services can talk to your containers. So EKS, you can install Calico, Tigera's Calico. Project Calico is probably almost certainly the most common network policy provider at this point. EKS will let you install this as an add-on. Again, add-ons, you do have to manage upgrades, you do have to manage the life cycle. AKS lets you choose between Azure or their Azure policy or Calico. Azure has this thing, AKS, a lot of these features, you have to opt in at cluster creation time. They're the only, for the most part, they're the only provider that require this. EKS and GKE, you can enable or install Calico at any time. It does mean for Azure that you do have to either plan ahead, or I would strongly recommend, if you're using Azure, I would strongly recommend finding and automating a way to migrate your workloads to new clusters, not just because you may want to opt into these at a new time, but because when they add new features, and they do this, they do add features. Azure is really good about keeping up with new features, but they may add a feature later on, 6 months down the road that you think is really great, but you have to do it at cluster creation time. So find a way to move your workloads. And all three of them support Calico. Azure also supports Azure Policy if you're using their Azure Container Network Interface, which these are all compatible though. They all have a standard interface. So if you have manifests that work on Calico, they should also work on Azure Policy. Next slide, security options, and network policy falls into this. But Kubernetes RBAC, at this point, you should be using their role-based access control. It's standard, it's been around for a couple of years. This is the way to manage what services and what users can, my cat has the zoomies, he was scaring me a little bit, sorry. So role-based access control, role-based access control manages what entities have what privileges on the Kubernetes API server. And as I mentioned before, API server, that's how you manage your cluster. EKS is always enabled. On AKS and GKE, it's optional, but again, Azure, it's one of those things where you have to opt in at cluster creation time. Pod security policies. PSPs are, I don't know if they're officially deprecated yet. I think they are. They will be. They will not, the Kubernetes team will probably not get rid of them until they have a viable alternative, which they don't right now. Pod security policies let you dictate what security, a subset of security options that a pod deployment can use. These mostly pertain to things like whether or not the container has root privileges and what user ID they can run as, whether or not they're using the host file system, the host network, and by host I mean node. So they're very, at this point, if you have a lot of pod security policies deployed, keep using them. If you don't, you may just want to go straight to something like, again, I mentioned Open Policy Agent Gatekeeper. Again, it does have a learning curve, but it has many more options for determining a security posture of your workload deployments. And just as a note, again, so containers, they're not really contained. The image is contained, but the name container doesn't. It's kind of a misnomer. Container processes are just processes on your node, and by node I mean your VM. So if you're running Linux, these are just Linux processes. You want to segregate your node from your container processes as much as possible for security reasons, because again, if a malicious agent gets in a pod and your pod is running with root privileges on your node, is using your host network, is using your host file system, they have too much access and they can pretty much take over the node, which means they can pretty much do whatever they want. So anything you can do to enforce best practices like pod security policies or another admission controller, you definitely want to do that. So by default on all three providers, the Kubernetes API endpoint is open to the whole internet. So that's obviously a bad thing. Even just as recently as late last year, we saw a pretty serious security issue around the API called the Billion Laughs attack, which was just a denial of service attack, but it allowed unauthenticated users to create a denial of service attack on your API endpoint. So you don't want your API endpoint open to the world. Best practice would be to make it private, which means that it's only accessible within the virtual private cloud your cluster is running in. All three support that. Again, this is one of those things, Azure, you do have to opt in initially. If you do need it, if you do need to manage it from, say, another VPC, which is not abnormal, especially if you're running a lot of clusters that are distributed either, like we said, either on-prem or multi-cloud, or even multiple regions in some cloud. You may need a public API endpoint. They all three do support using a whitelist though, so you can allow access only from IP addresses that you trust. EKS is nice. It will allow you to do both. And if you don't have a private endpoint, something to keep in mind is that any network traffic between your API server and your nodes, and this happens a lot because your nodes, they have to talk to each other, it goes outside of your virtual private network, and it should stay in your cloud provider, but it does mean that the traffic is not localized in your virtual private cloud. Another very strong security option would be to use read-only root file systems on your nodes. So that prevents, again, if a malicious attacker does get on your node, they cannot overwrite or install. They cannot install their, whatever malicious program they want. They can't install a crypto miner. They can't install any kind of kernel modules, but also it means they can't overwrite. So if you have a process, if you have a program, sorry, that gets run as root on regular access, they can't overwrite that. EKS and AKS don't support having read-only root file systems for the nodes. Google Cloud does. It's opt-in, and they only support it for their container optimized OS, but they do have that option.
Excellent. Karen, I hate to do you, but we're coming up. We've only got about 2 minutes left.
Oh, okay. Service limits. These are options. I won't go over these. We do have a blog post with it's a little over a month old at this point, but it goes much more in depth about this and other options. It's on www.stackrocks.com under the blog post. So, okay, that's it. Very quickly, takeaways. These managed services are not all the same. GKE is definitely the most mature. EKS is the least to manage. So users are going to have to do a lot more work to keep up with version support and security. Azure also requires a lot of hands-on. So, and again, blog posts, I would definitely, if you're interested, it's got a lot more information. Okay.
Guys, I would like to keep going, but I also have to respect everyone's time, including Karen and the rest of us.
Oh, I have time, but
we have a record of all these questions. We'll get them over to you, Karen and Michelle on StackRocks. You guys can answer the questions that are out there. We'll also have the recording of this up within a couple hours. We'll also have the full slideshow available for everyone. I apologize. Okay. Yes. I wish we had more time to do these things, but our webinars are an hour. Karen, thanks so much for a great webinar and so informative. Michelle, thanks for pitching in as well. I appreciate it.
Absolutely.
I do encourage everyone to look offline, and we'll be in touch. Until next time, this is Alan Schimmel for DevOps.com, Security Boulevard, Container Journal. Have a great webinar, or have a great day, everyone. Be well.
Okay, thank you, everyone.